Okay, so like I said in previous video, moving on to section 4, we're looking at our trig functions. Okay, so I said we were going to go into more detail about trig, and here's kind of what it is. So again, this is just an overview of all the trig that you've kind of learned previously, okay, and just kind of refresher. This isn't going into super detail on anything. This is more of a refresher. This is some of the stuff you're going to need for calculus. So first off, radians. I do want to say one thing is that we will go into more detail on some trig stuff that is more important as we move along. This is more of the stuff that we're going to kind of glance over going, okay, you guys know what this is. Okay, so radians. So first thing is whenever we're dealing with trig functions, we're always dealing with radians. We're not going to be dealing with degrees. Okay, so make sure everything's in radians, make sure your calculator's in radians, and all that. So a full circle is measured as 2 pi radians. So that means a half a circle is 1 radian, or a pi radian, and everything. So it's measured in radians, and they are opened counterclockwise. Okay, same direction as the coordinates or the quadrants in a coordinate plane. Okay, so you start at, in this case, P, and then you open upward in a counterclockwise motion. Okay, if you open the opposite direction, it ends up being negative. Okay, so if you open it up in a clockwise motion, it's negative radians. Okay, so remember, we're dealing with radians. So going from degrees to radians and radians to degrees. So the first one is if you're in radians and you want to say how many degrees you have, d is equal to r times 180 over pi, and the radians is equal to degrees times pi all over 180. You only have to know one of these because you can manipulate the equation to get the other one. But if you're ever in degrees and have to turn into radians, or you're in radians and turn into degrees, these are your formulas. Okay. And again, we're not going into super detail with this because you have this is not anything new to you, hopefully. All right, so SOHCAHTOA, some old hippie caught another hippie tripping on acid. We got SOHCAHTOA. This is for your right triangles. So I have a right triangle here with A, B, and C. Your adjacent, opposite, and hypotenuse. That's what the O, A, and H stand for. We have a little theta as the angle measurement. So usually we'll be using theta whenever we're talking about a radian, an angle. So sine is equal to the opposite over hypotenuse, SOH. Cosine is equal to the adjacent over hypotenuse, CAH. And tangent is equal to the opposite over adjacent. So again, SOHCAHTOA. This works for these ratios only in a right triangle. So if it's not a right triangle, then it's not going to, these relationships don't work as much. Okay, and that's where you use your law of sines and law of cosines. Okay, other trig functions that we have is our reciprocals of them. So secant, cosecant, cotangent. So secant is 1 over cosine, which means it's going to be the hypotenuse over the adjacent. Cosecant is 1 over sine, which is the hypotenuse over the opposite. And then your cotangent is your cosine over sine, which ends up being your adjacent over opposite. Okay, so those are your other trig functions. Again, you got to remember you have those, but yeah, okay. Okay, periodic functions. So periodic functions are functions that repeat themselves. So again, we're just going over kind of the shape of all these trig functions. All trig functions are periodic functions. They repeat themselves over a given interval. Sine and cosine repeat themselves over 2 pi as an interval. So you can see here the one on the left is sine, the one on the right is cosine. You can see it's just a nice smooth curve where you have a peak and a valley. Sine starts in the middle of it and then it peaks and then valleys for a normal sine function, while a cosine starts at its peak, bottoms out, and then ends at its peak again. Okay, so those are your basic sine and cosine trig functions. These are periodic, they repeat themselves. Here's your other ones. The first one is the one in the top left is our tangent function. And so a tangent function actually repeats itself only in pi units, pi radians, not 2 pi like the others. So they repeat themselves only in pi units. And cotangent is the one next to it. So as you see, it's just kind of a direction of going left to right or right to left. starting from the bottom going up or starting from the top and going down. Sine is increasing, your tangent is increasing, cotangent is decreasing. The bottom ones are our secant and cosecant. You can see underneath which one's which, and they start at 1 and -1, and then they have parabolas opening up and down, and these repeat over 2 pi radians because they are the reciprocal of sine and cosine, so that's why. All right, these identities. So the first one is our Pythagorean identity, which is kind of the one that's used the most. It's kind of the key one here. So we have sine x plus cosine, or sine squared plus cosine squared is equal to 1. And that's always true. And then from there you can manipulate it. You can divide both sides by cosine or anything like that, or sine, and that gets you your next 2. Other than that, all the other ones here, there's going to be this one and on the next slide. These are all different identities that you just want to write down, keep, use as kind of a reference to, and you can use these to help you manipulate equations to make them easier for you. Okay, some of them you'll use more than others. It just kind of depends on the problems that you run into. So take a second, you can write down all these identities. So here's more identities. So here's a few more that we have here, which is more dealing with when you're squaring it, and double angles and half angles for these. So take a second again, write these down. Okay. All right, last thing is law of sines. Law of cosines. Law of sines is just a proportion. Sine A over A is equal to sine B over B is equal to sine C over C. So we're not going into too much detail with that. But law of cosines is going to be one that you'll probably use more often because you can easily find any of the missing sides and angles. Make sure you have the law of cosines written down. If you want to write down the law of sines, you can as well. But it's, again, just simple proportions, so it's not a huge deal with those. Okay, so that's the law of cosines. Your homework today is going to probably be asking you to use a lot of this stuff, so make sure you go through all that. Okay, here's your homework today. Again, this is section 4 on there, so make sure you're pulling it out of section 4, and again, early transcendental. If it's not, it's going to be a different page.